Hello to everyone. In this class, let us discuss what is periodicity and variation of periodic properties. Okay, it is one of the important questions for IPE, that means for junior inter. Okay, in long answer questions, this is expected. So now let us see what is periodicity and variation of some important periodic properties in a period and in a group. Okay, let us see. So let us see first what is the definition of periodicity. So what is the definition? See here in the periodic table. Now what happens here, if you observe some properties, they can repeat it at regular intervals again and again. So now here the repetition of same property at certain regular intervals, that trend is known as which one? Periodicity. So the repetition of properties at certain regular intervals is known as a periodic property, and the trend is known as periodicity. So now here in the periodic table, properties of elements repeat at regular intervals of 2, 8, 8, 18, 18 and 32. So at these regular intervals, some properties, the same property repeat again and again. So like that here, the repetition of properties at regular intervals of 2, 8, 8, 18, 18 and 32 in the periodic table is known as which one? That periodicity. Those properties are called periodic properties. So what is the general example for this periodicity means here? For example, if today is the Wednesday, exactly after 6 days, we get the same Wednesday again. And again after 6 days, Wednesday only. That means here, Wednesday is one day that repeat again and again at fixed intervals. Of course, that repeat at fixed intervals. In the similar way, in periodic table, if you consider oxidation state of first A group elements, plus 1 is oxidation state of all first A group elements. Now here, the plus 1 oxidation state repeat again and again in case of first year group elements at regular intervals of which one? 2, 8, 8, 18, 18 and 32. That means here hydrogen atomic number 1, lithium atomic number 3, next sodium atomic number 11, potassium atomic number 19, rubidium atomic number 37. So francium atomic number. Okay, now cesium atomic number is 55. So these are which one? First A group elements. Now all these are having plus 1 oxidation state. That means plus 1 oxidation state is repeat again and again. So what are the intervals here? 2, 8, 8, 18, 18. Of course, after that we can get francium here 32. So like that here, plus 1 is the property. Let this take as periodic property. Plus 1 is a property that repeat again and again in the periodic table at regular intervals of 2, 8, 8, 18, 18 and 32. So like that, the properties which repeat at regular intervals of 2, 8, 8, 18, 18 and 32, those properties are called periodic properties, and that trend is known as periodicity. Now, in general, they give which one here? Explain the variation of that given for that periodic properties in a period and in a group. That is the question. But which periodic properties let us consider here as important? Let us see that. In that, so many we can discuss here. In that, the first one, if you consider which one? Electronegativity, and second one electropositivity, and third one electron gain enthalpy, We can also call this as electron affinity. And another important one is here metallic and non-metallic nature. Metallic, non-metallic nature. This is also one important one. And another fifth one is here acidic nature and basic nature. Acidic and basic nature. Okay. And of course, if you go for ionization potential, that is also we may consider here acidic and basic nature, metallic and non-metallic nature. These are which one here important periodic properties. Let us see one by one here. First one is electronegativity. So first we have to write the definition of electronegativity. What is its definition here? The tendency of an atom to attract the bond pair of electrons towards itself is known as which one here? That electronegativity. That means the tendency of an atom to attract the bond pair of electrons towards itself is known as electronegativity. Now here, let us see what happens in a group. So in a group, electronegativity decreases from top to bottom because as atomic size increases, nuclear attraction on that bond pair of electrons decreases. If you consider A and B atoms bonded here, let it be the bond pair of electrons. Now here, as the size of B atom is larger than A, nucleus is away from the bond pair of electrons. So this B atom cannot attract that electron pair strongly towards itself. But A atom, due to the small size as nucleus is near to this bond pair, this can attract strongly. That means as size of the atom increases, the tendency to attract bond pair of electrons decreases. So electronegativity decreases from top to bottom as atomic size increases. Okay, now let us see in a period. So controversial to this because in a period from left to right, what happens here? Atomic size decreases. As atomic size decreases, what happens? This electronegativity value means increases. So in a period from left to right, electronegativity increases. As the size of the atom decreases, that nuclear attraction on bond pair of electrons increases. So from left to right, electronegativity increases. So like this we have to write that. So first we have to give the statement what happens in a group and we have to explain the reason. Same in the case of in period also. Okay, this is regarding which one? That electronegativity. Okay, now let us see another property, which one? That is electropositivity. So what is the definition of electropositivity? Let us see here. The tendency of an atom to lose the electron is known as electropositivity. Now here in a group from top to bottom, as atomic size increases, now what happens here? That nuclear attraction on outermost electron decreases. That means this atom can lose the electron readily. That means from top to bottom, as atomic size increases, that electropositivity also what happens? Increases, because that easily loses which one here? Electron. So like that here, this electron is lost by this B atom easily compared with A atom, as nuclear attraction less on that outermost electron. So this is variation in a group. And if you come to in a period from left to right, as atomic size decreases, what happens? Electropositivity also decreases, because as the size of the atom decreases, nuclear attraction and outer electron increases. Therefore, this atom can't lose electron readily, so electropositivity decreases. So this is regarding which one here? Electropositivity. Okay, then let us see another one, electron gain enthalpy and also known as electron affinity. So what is electron gain enthalpy? Let us see here. So now the whenever the tendency to gain electron is known as which one? Electron gain enthalpy nature. Now here let us see the definition here. The heat energy liberated when an atom that take one electron, that atom gain one electron, is known as electron gain enthalpy. The amount of heat energy or the amount of energy liberated when an electron added to neutral gaseous atom is known as electron gain enthalpy. Now let us see what happens that value in a group. So in a group, what happens? Atomic size from top to bottom increases. So as atomic size increases, what happens here? The distance between nucleus and outermost electron also increases. As distance increases, this nucleus can't attract that electron effectively. That means here from top to bottom, as atomic size increases, electron gain enthalpy value decreases. But one important thing here, in every group, second element electron gain enthalpy is greater than that of first element. So we have to remember this point here. In every group, second element electron affinity greater than that of first element. Example, chlorine electron affinity greater than that of fluorine, because due to the very small size of the fluorine first element in a group, it has more electronic repulsion. So due to high electronic repulsion, this fluorine can't gain electron easily. So for this reason, due to smaller atomic size and high interelectronic repulsion, fluorine electron gain enthalpy is less than that of chlorine, Cl. So like that we have to remember, this is a trend in which one? In a group. Now let us see in a period from left to right what happens this electron gain enthalpy. So in a period from left to right, as atomic size decreases, electron gain enthalpy or electron affinity value increases. But up to 7th A group only we have to follow this trend, because in case of zero group elements, electron gain enthalpy value considered as 0. So that's why up to 7th A group, in a period from left to right, electron gain enthalpy increases, but for zero group elements that value taken as 0. So this is regarding which one? Electron gain enthalpy, that variation in a group and in a period. Okay, then after that next one is here which one? That nature of oxides. That means whether they are having which nature. Oxides of these elements are having which nature. Let us see here. So in that two things we have to discuss. One, what is that means here? What happens that nature of oxides, nature of oxides. So in this, first we have to see one thing here. What is that here? In a group, what happens? Nature of oxides from top to bottom and in a period. These the two things we have to consider here. First, let us see in a group what happens here. In a group from top to bottom, what happens here? Basic nature increases and acidic nature decreases. In a group from top to bottom, basic nature increases, acidic nature decreases. And in a period from left to right, let us see what happens here. In a period from left to right, basic nature decreases. What happens here means basic nature decreases, and here acidic nature increases. So like that, from first A group elements to seventh A group elements, basic nature decreases but acidic nature increases. So this is regarding which one here? Nature of oxides, that is acidic nature or basic nature, regarding that. Okay, then metallic and non-metallic nature. Let us see what happens metallic and non-metallic nature in a group and in a period. So see here. In a group, let us see first what happens these properties here. First one thing we have to remember here, electropositive character represents the metallic nature, electronegativity character represents the non-metallic nature. And we know that in a period from top, that means in a group from top to bottom, in a group from top to bottom, what happens here? That electropositivity value increases. Electropositivity value increases. As electropositivity increases means what happens here? Metallic nature also increases, but non-metallic nature decreases in a group from top to bottom. Now in a period, controversial to that above statement here. So in a period from left to right, what happens here? Electronegativity increases. As electronegativity increases, what happens here? Metallic nature, metallic nature decreases, but non-metallic nature increases. So like this, we have to remember which one? The trend of these periodic properties in a group and in a period. So this is one of the important questions, that to long answer question for intermediate public exams. Okay, bye.